everyone, welcome to my lesson. I am Zhee Piang. Today we are going to learn nuclear energy in 15 minutes. This topic is under Form 5 syllabus, Chapter 6, Nuclear Physics. Before I introducing you all the learning standard of today's lesson, let's have some statistic information about nuclear reactor. As of October in 2021, there are 441 nuclear reactors in operation. Here are the majority countries that operating nuclear reactor, which are United States, France, China, Russia, Japan, South Korea, India, and others countries. While Malaysia is not in the line, but our country do have a nuclear reactor located at Bangi, which is for research purpose only. So, do you know what is nuclear reactor? I will introduce you the general concept of what is it. Nuclear reactor is the heart of a nuclear power plant. Nuclear reactor contains and controls nuclear chain reactions that produce heat. And that heat is being used to make steam that spins a turbine to create electricity. These are the basic concept of a nuclear reactor in words. And now let me show you a visualized version. This is a visualization about the whole process in generating electricity. The red circle indicates the structure of nuclear reactor in generating electricity. So, are you eager to know what is the relationship between nuclear reactor and nuclear energy? Let's get back to the function of nuclear reactor. Do you remember that I have mentioned that reactions happen inside a nuclear reactor? So what is the reaction that need to be controlled? What is the meaning of nuclear chain reactions? These have led us to our first learning outcome. Communicate about nuclear reactions, which including nuclear fission and nuclear fusion. Nuclear reactions are categorized into two types, nuclear fission and nuclear fusion, and both reactions will produce nuclear energy. Therefore, the relationship in between is nuclear reactions take place inside nuclear reactor and the reactions produce nuclear energy. First, I will talk about nuclear fission. Nuclear fission is a reaction when a heavy nucleus splits into two or more lighter nuclei while releasing large amount of energy. With these words, you might not fully understand about it. Here I give you an illustration. A heavy nucleus uranium-235 is bombarded by a neutron, then it becomes an unstable uranium-236. Then the unstable nucleus undergoes nuclear fission process, which is splitting into krypton-92, barium-141, and 3 neutrons. Besides of lighter nuclei, energy is also released. And this is the full process of nuclear fission. Next, we will move to nuclear fusion. Definition of nuclear fusion is reaction in which small and light nuclei fuse to form a heavier nucleus while releasing large amount of energy. Same as just now, I will further explain it by an illustration. Given here two types of small and light nuclei, which are deuterium and tritium. The two nuclei fuse to form a heavier nucleus, which is helium. Large amount of energy is also released. same as nuclear fission process. But there is an important point that you should know. Nuclear fusion happens under conditions of high temperature and high pressure. So, after knowing about these two nuclear reactions, do you able to list out any comparison among them? Maybe in terms of definition? Let us compare among nuclear fission and nuclear fusion. The first comparison is nuclear fission involves heavy nucleus splits into two or more lighter nuclei, while on the other hand, fusion is about small and light nuclei fused to form heavier nucleus. Second, splitting of nucleus in fission will release huge amount of energy, while the energy being released in fusion is several times greater than fission. Furthermore, nuclear fission do not occur naturally, but fusion occurs naturally in stars and sun. And the last comparison is about energy required for the process. While little energy is required for splitting in fission, but high energy required for fusion. So, with the comparison of nuclear fission and nuclear fusion table just now, we have done for our first learning standard of today. So, what is the next? With this table, I would like to ask a question. Which reaction that you think is more suitable to be used in the nuclear reactor to generate electricity? You have 3 seconds to choose your answer. 3, 2, 1. The answer is nuclear fission. This might be because energy required for fission is lower than fusion. Do you get the correct answer? I hope you do. Next, we will proceed with second learning standard. Describe generation of electrical energy in nuclear reactor. This is the illustration I have shown to you at the beginning. Nuclear reaction takes place in the nuclear reactor, where nuclear reactor is the key point in generating electricity. We will discuss the whole process by parts. The generation process started with nuclear fission of uranium-235 inside the nuclear reactor, and its chain reaction will produce heat energy. At the same time, water is pumped into the reactor core to absorb heat energy produced. The water will be boiled by the heat energy. Then, the boiling water will produce high-pressure steam which will be channeled into the turbine. When the high-pressure steam is being channeled into the turbine, it will rotate the turbine and further rotating the magnet or coil in generator. The steam will condense back into water and flows into condenser. Finally, the rotating magnet or coil in generator will generate electrical energy and send it to consumers via power supply transmission system. So, this is the full process of electricity generation. And for sure that electricity generation is in a continuous form to ensure the supply. So how to make it continuous? We might trace back it to the first stage of process. The first stage of process is nuclear fission of uranium-235. There is a term chain reaction. So what is chain reaction? How does the reaction happen continuously? As I mentioned just now, nuclear fission of uranium-235 and its chain reaction is the first stage of electricity generation process. Here, the process is starting with typical fission of uranium-235. And uranium-235 is being attacked by a neutron, then it undergoes splitting process and produces two nuclei, which are krypton and barium, three fast-moving neutrons, and a large amount of energy. Then, these three fast-moving neutrons will bombard other uranium nucleus, then the nuclear fission process happens again. And more neutrons are being released through the continuous fission process. And here is the full illustration of the continuous process. While this whole continuous process is called a nuclear chain reaction that happens in a nuclear reactor. Again, with this illustration of electricity generation process, we know that the chain reaction is happening inside the nuclear reactor, followed by other processes to generate electrical energy for us. So, these two learning standards for today's lesson are fulfilled. Please don't leave first. As usual, we must have some questions to test your understanding. Please take out a piece of paper and answer the following questions. There are 6 questions for you. Question 1. The process of splitting a nucleus into smaller and lighter nuclei is called. Question 2. The process of combining the nuclei of atoms to make different atoms is called. Question 3. Where does fusion occur naturally? Question 4. Which form of nuclear reaction releases an enormous amount of energy? Question 5. Nuclear energy uses what to turn turbine to power a generator? And question 6. What is a chain reaction? And I'm allowing you to pause my video for around 20 minutes to answer these questions. When you are watching this slide, means that you have successfully answered all my questions. So for question 1, the process of splitting a nucleus into smaller and lighter nuclei is called as nuclear fission. The process of combining the nuclei of atoms to make different atoms is called as nuclear fusion. And nuclear fusion occurs naturally in stars and sun. And for question 4, both nuclear fission and nuclear fusion release an enormous amount of energy. Question 5. Nuclear energy uses high-pressure steam to turn turbine to power a generator. And for the last question, chain reaction is a continuous nuclear fission which starts from fission of uranium-235, produce nuclei, neutrons, and energy. Then the neutrons bombard other uranium-235 again. At the end of today's lesson, I have prepared 2 triggers for you all. The first trigger is, how can we control the energy produced during the chain reaction to ensure that a nuclear reactor is safe for electricity generation? The second trigger, what can happen when a fission chain reaction is getting out of control? Please do some research on these triggers and bring back the information that you have during my next lesson. Thank you for your time. See you.